So yeah, good morning, everyone. Welcome to our first online workshop in the kind of context of the EU CRCF certification framework methodology development. We're kicking off with a workshop on the biochar methodology development. I'm just going to give you a very brief outline of what we're going to do today before handing over to Christian Holzleitner, head of unit at DG Klima, in charge of the development of methodologies. So following a kind of a brief introduction of our work, of the context of the CRCF, and kind of the process so far and in the future, we are going to have a presentation from Chris Mallins, our external consultant who's working with us in supporting the European Commission DG Klima on the development of methodologies. Chris will give a brief presentation of a draft paper that has been prepared to support the development of the biochar methodology. So this is a first step in the process, but I'm not going to say too much about it and not to spoil it. And then we're going to go into two sessions where we're going to discuss in detail some of the technical aspects and challenges related to the development of biochar methodologies, kind of looking at what has been done so far in terms of kind of existing certification schemes and certification methodologies. We have a little chat function on the side where you can drop your questions. We've asked you to submit some questions online already, so we're going to prioritize those during the Q&A sessions, but otherwise we're going to, in the interest of time, we are still going to try and pick up some of the questions, well, as much as we can. So each of the kind of panelist sessions are going to have a Q&A at the end, so feel free to drop the questions in during the discussions. A brief reminder that we are filming this. So you know, I don't think anyone's names are visible, but I do think that maybe questions are visible. So just so you're aware, we're filming this, and there's a chance, I believe we are going to put it on our website, so it's available for people to look at afterwards. Okay, so I think that's it, and yeah, I'm going to hand over now to Christian, and we're going to share some slides as well. So if you don't see the slides, please let us know. Otherwise, yeah, happy biochar methodology online workshop to everyone. Let's see here.
Okay. Also, good morning from my side. Yeah, happy to be here and happy to see the big interest in biochar. So we are at 213 attendees, and I think we have registrations in like the 500s. So yeah, very happy about this. Hope we can deliver an interesting session for you, and we can, I mean, most importantly, make some progress in developing the methodology for biochar. I'll do a general introduction, set the background, get you in the mood then for the more technical discussions. So, as always, I start from this one big objective that we have in EU climate policy, and this is to make Europe climate neutral by 2050. So this means, on balance, we don't add any more CO2 to the atmosphere, and this is what counts. So for this, we need to reduce our emissions, the use of fossil carbon, the burning of fossil carbon, very quickly and very significantly. But we'll always have emissions in the system. So we also need to get better in getting the CO2 out of the atmosphere and storing it in our soils, in our forests, in the products that we produce out of it. And a share of it will also need to put back from where we've taken the carbon initially. So like the empty gas and oil fields of the North Sea. So overall, I think you can say that there are three keys to unlock that climate neutrality. So in the first place, it's about using more renewable energy. So by 2040, we should use, like, I think around 80% of renewable energy in our energy mix, and of course we should use it efficiently. But we'll still need carbon in the industry. We'll need a new circular carbon economy. So we'll need to switch from fossil carbon to other forms of carbon, so biogenic carbon, carbon that we get directly out of the atmosphere, and then use that carbon much more sustainably in our construction materials, in the chemical sector, as bioplastic, keep them in the product as long as possible. And then finally, if we demolish things, then we put it back underground. And of course, here biochar can already play an important role, for example, as construction material. And we'll also need to use biogenic carbon still as a source for energy, as a fuel, and so on. And also here, biochar can play a role as producing sustainable, in climate positive heat or fuel. And of course, the third component for climate neutrality is the bioeconomy itself. We need to get ready for 2040, 2050, not only to produce food, energy, but as I said, also the feedstocks for our chemical and construction industry. So we really need to manage our agriculture, our forestry in a very sustainable way. And this is something we need to be looking into. Also, when we discuss about biochar, what is about the sustainable sourcing of the biomass that we would be burning. So if we all manage that well, we can achieve a 90% net emission reductions in 2040. So how would our economy look like in 2040 in terms of the emissions and removal profile? So we estimate that we would have like around 850 million tons of emissions. And what is already like a very important feature is that we would only have like 160 million tons from industry. So our biggest source of emissions would come from the agriculture sector, from fertilizer, from livestock, around 300 million tons, so down around 25% compared to now. And then we would balance by 400 million tons of removals. So there we estimate that around something between 300 and 350 million tons would come from the LULUCF sector, so from the land use, so the storage we have in our soils, our forests, and in the products we produce out of it. But for the remaining rest, for 80 to 50 million tons, there we would look into bioenergy with CCS, direct air capture with CCS, and biochar can play a very important and significant role there to get us to these 400 million tons of removals that we need. So how do we think that we can unlock this potential of biochar and of other removals? So the first thing we need to do, what we always do in climate policy, is to look at the monitoring, reporting, and verification. So for this, we have agreed with the member states and the parliament the carbon removal and carbon farming regulation, so the certification regulation, where we want to determine what a certain technology can do. So how much carbon is stored, for how long, what are the impacts on sustainability, what are the impacts on other types of emissions that could be generated here. And so on the one hand, we're looking into permanent removals like bioenergy with CCS, direct air capture CCS. And I think a key discussion point for today will be, how permanent is biochar? Can we confidently say that biochar is a permanent carbon removal? And then we set that apart from other more temporary carbon storage in soils, in forests, in products like wooden and bio-based buildings. So we are very clear on which type of removal this is, for how long it's stored. Because we have permanent removals that offer that advantage. You have more temporary removals that may have a lot of benefits, for example, for biodiversity. And we want to be very clear about that. And for this, we've set up a whole certification process that I quickly want to present to you on the next slide. So how would that certification work? So we've agreed the framework, the quality criteria that you find also in a lot of other certification schemes in the voluntary market for now, that you would also find in similar ways in our emission trading system. So it's about robust quantification. It's about the additionality. So is this an additional ton of CO2 that is removed from the atmosphere? It's about liability, rules like under the CCS directive, and it's about sustainability. And I think this sets us apart a bit from existing certification schemes, is that both the Parliament as well as the member states want us to put a lot of emphasis on sustainability. So if we talk about biochar, it's about from where do we get the biomass that we are burning? Is this sustainably managed? Are we taking care of the cascading principle? And also, what is then done with the biochar? So the biochar should, of course, not create air pollution, not have any negative effects on the environment. So, and these are the principles. Now we need to make them operational. This is what we are very much doing in this workshop. What we are doing with the expert group, we want to build on your knowledge in establishing this certification methodologies, and really want to find the state of the art that that we can establish based also on all your experiences, based on the latest scientific results. Then in terms of the process, we want, of course, welcome the existing public and private certification schemes that we already have and integrate them in our standards and help you to make a credible business case. And of course, then we will have an independent certification, third-party certification by verifiers, which we call certification bodies. The certification bodies will issue the audit reports, the certificate of compliance. It's also possible that several operators get together in a group of operators to save on administrative costs. So, and then, that was a big demand again from Parliament and member states. We are working towards setting up a union-wide registry by 2028, and that should really deliver all the transparency, all the safeguards against double counting that everyone wants. So there will be public access to the audit reports, to the certificate of compliance, and the certificate of compliance is a very important document with us, because there you will also have all the indicators on the sustainability, and then you will have the units that you can trade, and there will be different units depending on whether it's a permanent removal, it's carbon farming, sequestration, or it's a soil emission reduction. So very clear difference between permanent and temporary removals. And I think there we come to some of the key questions that we will address today. So how long-term is biochar? Can we confidently say that biochar is a permanent carbon removal? And that links very much together with the different uses that you can have from the biochar. So on agricultural soils, or whether you can incorporate it into building materials. So how much carbon will be inert, can be stored for the long term there. And of course, if we talk about agricultural soils, as already said, also here sustainability is a big issue. Can we be confident that the biochar doesn't lead to air pollution and so on? So how do we ensure that we don't do significant harm to the environment? I'm using this technological or this technical word from the taxonomy, the do no significant harm principle. So, and then of course, is there a difference in the permanence, in the longevity, if we use a biochar, or if we put biochar on the fields, if we use it as a nutrient, or whether we use it in buildings, in building materials. Okay, so these are the key questions that we hope we get some insights today, and I'll finish with the next slide. So what's next for the biochar methodology? We're discussing today the technical scoping paper, and we hope that based on that we can already develop a draft methodology for the expert group meeting that will be in the week of the 20th of October. And then based on your input there, maybe we manage to have a draft methodology by April next year that we could discuss in the expert group meeting, and then go into the legislative process and propose a delegated act. So this timeline, of course, depends a lot on your inputs, on your views. Can we agree on the way forward? From our side, we are very keen to go ahead, but of course, it depends a lot on your expert views that we are relying on. And then, so if everything goes well, and then we could start this overall the certification maybe in 26. So still for now, for the voluntary market, where we hope to provide more clarity, more transparency. But then, of course, what we will also discuss in other fora is, okay, how does our climate policy post 2030 look like? What do we do with our emission trading system? How would we integrate permanent removals in our ETS? What would we do for the land sector? How would we give their financial incentives for more sustainable agriculture and for more removals? We'll have separate events on that, and we're also trying to work more on the financing side. So there will be some workshops coming up in the first half of 25 on how we can provide more public financing through our research programs, but also maybe mobilize more private capital. And yeah, but the key to all of this is, do we manage to have a credible certification methodology that can really show with biochar how much carbon is stored for how long and how sustainably is it done. With that, I wish all of us a very interesting seminar, and hopefully with operational conclusions at the end. Thanks a lot.
Okay, well, over to you, Chris.
Thank you very much, Andrea. Am I coming through loud and clear? Is someone confirm? Yes, okay, I'm heard. Great. Well, good morning, everyone, and thank you very much for joining us. Hopefully now, let's see, if I actually click that, then you ought to be able to see my slides. So welcome everyone in. As Andrea mentioned, I am Dr. Chris Malins. For those of you who don't know me, I work with a little consultancy called Serology on this project supporting DG Klima. I am also working with ICF International and with Fraunhofer ISI. To give a quick, there we are, a quick review of the agenda for the next couple of hours. We are going to talk for the first half of this session about issues specifically relating to long-term storage and the permanence of biochar. We will have a break, which I think at this point will probably be maybe more like 10 past 11. And then we will have a sort of a broader session to close, covering other issues, and that in particular is going to be informed by the questions that we have had in advance of the meeting and by additional questions that you give us. We also have some panelists who will be joining us in the permanent session. We have Hamid Saneh of Aarhus and Cecilia Sundberg from the Swedish University of Agricultural Science. In the second session, we have Martin Pigeon from Fern. Then I believe both, or at least one of, Amelie Tokkesdal and Julie Marie Dedding Nielsen from the Danish Ministry of Climate, Energy and Utilities, and Anna Lerner from Carbon Future joining us. So just to give a few introductory comments, and hopefully, because I know that we have a mixed group, or I'm assuming that we have a mixed group online, just to give a little bit of grounding on how we understand this question of biochar. Biochar is a material and charcoal-like, or a form of charcoal that can be produced when biomass is heated in anoxic conditions, which leads to the carbonization of the material. So by applying heat, you can reduce the hydrogen and oxygen content, increase the carbon content, and by doing so, you can increase the stability of the material in the environment against decay. So biochar, and in particular, a biochar that is produced to have characteristics that favour permanence, can have a very much lower rate of decay, of carbon loss, than the source biomass would in the environment. The characteristics of what is produced depend on both the temperature and duration of the heat treatment process, and on the input biomass feedstock. You get a sort of a quite distinct biochar from processing wood than you do from processing a sort of a lower quality resource like sewage sludge, for example. And the primary method for biochar production is what is referred to as slow pyrolysis. And that's a process that uses temperatures in a range from 350 degrees up to maybe up to approaching 1000 degrees centigrade. But biochar can also be produced by a fast pyrolysis process. Fast pyrolysis is optimized generally to produce pyrolysis oil. Slow pyrolysis is more optimized to produce char. So different yields from those processes. The fast pyrolysis version is more likely to be used with a focus on producing, for example, renewable fuels under the Renewable Energy Directive, say. You also get a biochar from gasification. So gasification is a higher temperature process with the aim of producing syngas, carbon monoxide and hydrogen, and that has a significantly lower yield of biochar, but there is still material produced. And you can produce biochar from hydrothermal carbonization. This is a process that tends to run at a lower temperature and therefore produce a biochar with lower permanence. So we understand hydrothermal carbonization as likely to be less relevant to this work on permanent carbon removals. Now, it is pretty much broadly agreed that biochar can, at least in principle, remain stable in the environment for hundreds or thousands of years, depending on the characteristics of the material produced. And biochar can be applied to agricultural soils. This is a way of storing biochar, but it also can provide agricultural benefits. So there are a range of potential benefits in terms of things like water retention, fertilizer retention, and enhancing organic carbon storage potentially that have been associated with biochar use in agricultural soil. It can also be incorporated into concrete or other materials. This will potentially, and certainly for higher inclusion rates, affect material properties. And there's some potential advantages to using biochar in these materials, and some potential disadvantages as well. So the use of biochar in materials has to be carefully assessed based on the use of those. We have several existing voluntary schemes which are available and that identify biochar use as a form of carbon removal. The review paper, which we'll speak to a little bit more in the second part of the session, identifies 5 active certification systems. And as Christian and Andrea have said, the Commission have engaged with the ICF Fraunhofer and Serology team to develop a draft certification methodology for permanent carbon removal through biochar. And as some of you will be aware, we are also working concurrently on direct air capture and on bio-CCS methodologies as well. And as was mentioned, we aim to present a straw proposal to the expert group meeting in October. In case anyone isn't aware, any of the documentation, for instance, this review paper and papers relating to the DACs and the bio-CCS streams, as well as recordings of previous expert group meetings, are all available on the European Commission's expert group website. So the first part of our meeting today is going to focus in a little bit of detail on the question of long-term carbon storage in biochar. Clearly, biochar as a form of carbon storage is somewhat distinct from looking at, say, geological storage of CO2. The carbon is stored in the form of carbon rather than in the form of carbon dioxide. So that means that in principle, it can be subject to combustion or other oxidation processes. So there is a very important technical question relating to how long we expect the carbon in biochar to be stable and stored in both soil applications and other applications. And there are two main approaches which we're going to talk about to characterize this permanence. So one option which has been used and which is invoked in several of the existing standards is to construct some sort of mathematical decay function. So a function which is parameterized by time and by some combination of other bits of information about the biochar, and that gives you an expected rate of carbon loss or a forecast rate of carbon loss. And these functions are derived based on observations of biochar decay and biochar carbon loss that are undertaken in laboratory conditions. The properties that are used to parameterize these functions are generally some characterization of the biochar. The hydrogen to organic carbon ratio is sort of the standard property that's used in principle. You could also use an oxygen to organic carbon ratio. If you recall, I mentioned that the carbonization process involves reducing the number of hydrogen and oxygen atoms in a sample. That therefore reduces the ratio of hydrogen to carbon or oxygen to carbon. So it's a way of characterizing the extent of the carbonization of the sample. You can also characterize by process characteristic and notably temperature. A higher temperature process is expected to lead to a higher degree of carbonization than a lower temperature process. Feedstock characteristics may also be relevant. Biochar can be produced from a range of different forms of biomass, and it's certainly demonstrated that there are some differences between biochars depending on the biomass from which they were produced. And environmental characteristics for the place of storage of the biochar are also potentially important. So notably, soil temperature is used as a parameter in some existing approaches. You could also look at things like soil moisture content, soil acidity, various other properties. And the time over which we will consider this, the time over which permanence will be assessed, is also very important. One can set up these functions and parameterize them to look for expected carbon residence after 100 years, 200, 300, 500, 1000 years. In principle, the mathematics allow you to pick any number, but of course this is a decay function. We're not modeling mechanisms for additional carbon formation in these decay functions. So the longer the time period, the incrementally lower the estimate of stored carbon is going to be. And an alternative approach is, instead of focusing on decay functions and parameterizing by the results of these previous experiments, to focus on finding ways to actually assess a sample of biochar and identify some fraction of it as having high durability. And in particular, we have in the review paper, and we'll talk about this a little bit more today, discussed the idea of identifying a fraction of biochar as consisting of inertinides. And if you're not familiar with that term, I'll explain it a little bit more in a few moments. So to start off talking in just a little bit more detail on decay functions, the Intergovernmental Panel on Climate Change has published a method for estimating the change in mineral soil organic carbon stocks from biochar amendments. That method is not a finalized method. It is framed as a basis for future methodological development. So it's important to recognize the status of that methodology. But that method is based on a two-pool, I think primarily a two-pool exponential fit to incubation data. What this means is that you do a mathematical fit to the decay data from incubation experiments, which treats the biochar as if it is composed of two pools. One of those pools is going to have a higher rate of decay. One of those pools is going to have a lower rate of decay. And this can be thought of as corresponding to what are sometimes referred to as the labile and the recalcitrant fraction of the carbon in the biochar. In the IPCC method, the calculation is parameterized by temperature. So there are three regimes: temperature below 450 degrees, temperature going from 450 to 600, and temperature above 600. And it's important to note that this IPCC method is imagined as a basis for national inventory reporting. So one of the reasons that it uses this fairly low resolution temperature approach is that it's not assumed that the national authorities have access to biochar samples to test them. So that is perhaps a little bit distinct from the certification cases that we are talking about, where you assume that the party applying for certification does have access to the biochar and is able to do additional testing on it. And this methodology informs the permanence assessment rules that have been set in the biochar methodologies for the VCS standard and for the C capsule standard. That work has been developed in a paper in particular by Wolf et al. That was published in 2021. This is built on the same basic data set as IPCC, I think with a couple of additions, and it is a 2 or 3 pool exponential fit was provided by Wolf et al. So going from 2 pool to 3 pool tends to, the mathematics essentially divide that labile carbon pool, the lower residence time part of the sample is split into 2 parts rather than a single part. So you get a decay function, which in some sense has a little bit more resolution. And the functions in Wolf et al. Can be parameterized either, again, with regard to process temperature, distinguishing, I think, the same or similar temperature categories for pyrolysis as in the IPCC method, and adding a 4th gasification category. Or else can be parameterized directly by hydrogen to organic carbon ratio. And the paper lists residence times at the 100, 500 or 1000 year points. But in principle, that work could be generalized to give results to any time period that was considered relevant. And this has also informed permanence assessment in several of the operational standards. So Puro, VCS, which refers both to Wolf et al. And IPCC, and the reverse standard all refer to this. And just for as a little bit of an example, I have included at the bottom there some decay curves based on the Wolf et al. Work. So on the bottom left, you see a graph which is parameterized by the hydrogen-carbon ratio, which is set for a 500-year permanence period. And hopefully you can see that. And we also have 5 lines depending on soil temperature. So for a relatively cold soil and a very low hydrogen-carbon ratio, the Wolf et al. Work still forecasts that the vast majority of the biochar will be in place after 500 years. But as the soil temperature increases and as the hydrogen-carbon ratio increases, these functions assume an enhanced decay rate. So for a relatively high HC ratio biochar at 25 or 20 degrees soil temperature, you can see there that these functions at a sort of a 0.7 hydrogen-carbon ratio, which is the highest that is allowed in several existing standards, we're forecasting only maybe 15 or 20% of carbon remaining. So the parameterization is important, and you can see that is going to make a significant difference if these functions were used. There's a significant difference there in the number of carbon removal units that could be issued. And also just to illustrate the difference between different time assumptions or different time requirements. On the right hand side, this now for a 15-degree soil, again with the hydrogen-carbon ratio on the x-axis, you see that there's quite a difference between the expected carbon residence after 100 years at the top versus 500 or 1,000 years below. So these exponential decay functions sort of implicitly assume that all of the carbon in the biochar will eventually be lost. That's just the nature of the mathematical function which is being used. And there are several questions that my team has been looking at and trying to understand, and that we're going to talk about a little bit, hopefully, in the Q&A session about the use of decay functions. I mentioned this idea of 2 or 3 pools. We have results from Wolf et al. And also some more recent results from Azzi et al. From 2024, which use a slightly expanded data set and present a sort of a wider set of functional fits. And as I mentioned, for a 2-pool fit, we're talking about the small labile fraction. This is really 1 or 2%, maybe even less than 1%. Of the material, and this can be thought of as reflecting sort of volatile particles which remain on the surface or in the biochar during the pyrolysis process. So some molecules that could have become part of the pyrolysis oil or a pyrolysis gas but have remained fixed temporarily. So fixed is not a good word in this context, but let's say remained attached to the biochar. And then a larger recalcitrant fraction, 98 to 99%. And if you look at the results for a 3-pool model, you get a sort of a similar picture. You get typically a quite small, most volatile part, then a somewhat volatile fraction, which is still very much at this labile end, so maybe up to 2.5% between them, and then the significant bulk, which is treated as a single pool in this mathematical form, 97-98% of the material in the recalcitrant fraction. So we have no resolution in this version of the mathematics on any difference that you might have between decay rates within the more recalcitrant fraction. We could also have sort of questions around the fitting. Anyone who's interested in functional fitting, this is discussed in the Azzi paper. So different fitting algorithms even can give slightly different answers. And you can, instead of using an exponential model, use something that we refer to as a power model. And sort of the mathematics of the power model can be thought of as describing biochar as a sort of an infinite series of little pools that get more and more recalcitrant as you go on. And the practical upshot of looking at these power model fits instead of an exponential fit is that you tend to get a function that assumes perhaps a similar or even slightly higher rate of decay in the short term, but a lower rate of decay in the longer term. And on the right, I'm not going to fully explain this graph, but just to illustrate that these parameterization and function choices are important, I've shown an orange line. This is, I think, for 20 degrees soil temperature and 100-year residence. The orange line is the Wolf et al. Function, and you can see some different variations on that I've taken from the Azzi et al. Work, and with different ways of fitting to the hydrogen-carbon ratio and with a power model in some cases instead of an exponential model. So we have different mathematical forms that are going to give us slightly different answers, and certainly if you look going down to the sort of the higher hydrogen-carbon ratios in particular, this is going to make a meaningful difference to the number of carbon removal units that you might issue. I also mentioned this idea of identifying a high durability fraction of the biochar. And I mentioned that these functional fits implicitly assume that the whole of a sample is going to biodegrade eventually over a sort of relevant time frame, although potentially still thousands of years. There's work, and an example of this, which we've talked about in the review paper, is Sané et al. From 2024, which points out that you can analyze a biochar and identify, especially for the commercial biochars that have a slightly lower hydrogen-carbon ratio, that they are constituted primarily what is referred to as macerals, which are comparable to inertinite macerals that you find in coal. And of course, coal has been stable in its environment, possibly a little bit deeper than we're talking about with biochar, but has been stable for millions of years. And the literature on inertinites is reasonably clear that you expect these to have really a very long residence period. Although I think there's not a clear consensus in the literature. I think Sané et al. Notes that some of this sort of knowledge from the petrochemical engineering science has not necessarily always been something that biochar scientists have been familiar with, so there's not necessarily a full consensus on this point as yet. But the argument is that these inertinite macerals in particular can be expected to experience essentially no carbon loss on timescales that are relevant to the climate transition. So hundreds getting into thousands of years, you would expect very, very little carbon loss from the inertinite macerals. And Sané proposes a experimental method to assess inertinite content. I am not going to give a detailed explanation of how this works, but it's referred to as RO reflectance testing. And it's possible to identify a sample as having its reflectance above 2% across an entire sample, and thereby identify that all of those macerals appear to be inertinite macerals. So the argument given is that the fraction of a biochar that is experimentally identified as coming from inertinites could be treated as having a zero effective decay rate. And I have found these arguments reasonably convincing, but as I say, I don't think that there is yet consensus on this point in the academic community. And just to close, before I invite Hamid and Cecilia to say a few words, just with another little example, if we imagine a biochar that has a hydrogen-carbon ratio which is quite low, say 0.2, that can be analysed and is shown to consist of 2% more volatile material and 98% recalcitrant material, which is entirely inertinites. If we assess the permanence on that sample over 500 years at a temperature of 10 degrees centigrade, using the Wolf et al. Function, we'd give carbon removal units on about 74% of that sample. Following the inertinite assessment logic, you would award carbon removal units on 98%, And for a power model, depending on the parameterization, I would expect to see maybe 90% or more of that receiving carbon removal units. So this is an important question. The way that this is dealt with in the methodology is going to affect carbon removal unit issuance. As I say, most of those methodologies which are already extant are using some sort of decay function. So there's not an active methodology that uses an inertinite assessment at this time. And in this example, these differences would be higher if you go up to higher soil temperatures. That makes quite a big difference when looking at the Wolf et al. Or other decay functions. I have a few questions that I'm going to queue up for the discussion section, and then we will go to the discussion. So I'm asking, should a biochar certification allow permanence to be assessed with RO reflectance testing? Should it allow applicants to assess permanence based on a decay function? So we're not ruling out offering both of those as options in the first proposal. And for decay functions, there's a question, what time period should be required? We have the language of several centuries in the agreed text. If we use a decay function, should we have different decay functions for soil and material applications? And I'm going to stop there and invite, I'm not sure whether we'd agreed the order. Can we have Hamid to speak first? Have Hamid and Cecilia been given the option to speak?
Can you hear me?
Yes, Hamid, I hear you.
And I don't have a camera. I'm very sorry. The technology doesn't work today for me.
No problem.
So you want me to start?
Yes, Hamid, if just a few minutes of observations, that would be great.
Well, Chris, thank you very much. Very, very nice summary. We've talked about this before, but probably the audience would think, these methods are radically different. They're actually not. They're very similar. And it all boils down to the question, what are we decaying? Let's say if we go with the decay function, and you talked, you mentioned that there are two pools model or multi-pools model. One is labile and one is more inert fraction. But when you decay something during 1 to 3 years, 4 years of incubation, what are we actually decaying here? Are you able to answer, Chris, or you want me to go as a monologue?
I was expecting a monologue. I can respond if you would like me
Okay,
to.
all right. My observation is what we are decaying in the soil incubation. There are amazing science. All of them are a state of the art. There's nothing wrong with the multi-pool modeling. Everything is we are in agreement. But we think what you are decaying is the labile fraction. In fact, none of the hundreds of experiments and the models associated with the experiments have documented or demonstrated the decay of the inert fraction. That means essentially the decay of inert fraction remains non-empirical. So if you are modeling a decay of something which is very labile, obviously you're getting a very low permanence. And that's the core of difference. We think the permanence suggested for biochar, one of the most, some of them are almost equal to graphite, or the most resistant form of organic carbon on the Earth's crust. We think the numbers suggested are extremely, extremely low. It's impossible that we would have such a low permanence for the material like that. Now you're asking, okay, well, how do we model it? Sure, we could use the decay model, but we have to recognize that goes to the parameterization that you mentioned. We need to actually recognize that there are the inert fraction in the model. So that means you could use the actual bacterial or soil incubation data for what it is, for the fractions that is truly degrading, which can be very well measured. We know these are labeled fractions. And then when it reaches the inert fraction, then we need to either use geological perspective or use alternative way to establish that K decay constant, because that makes a drastic difference, that K number. You know, you could show the hydrogen to carbon ratio with F-perm relation. All of those are fantastic. These are great. But what does go inside that F-perm? It all boils down to that K constant. Remember, we are talking about exponential decay. You change that K constant a little bit, then you're going to get drastically different results. So what we are fitting with the empirical data is based on labeled fraction. The second thing that I want to say, the Karen model, it's not a two-pool model. It is a one-pool model. I know it's it's advertised as a two-pool model, but on average, the division between the two-pool model is a 98% and 2%. That means if you remove the first model, it makes absolutely no difference. It's a really single pool model that's being used, and that single pool model happened to be a labile fraction. And we're getting a very, very drastically low permanence results, which does not explain anything on earth science. In fact, if biochar can be degraded within 100 years, biochar that is being aromatized at a temperature of 700 degrees. If you tell me it would be degraded to 100 years, I'll tell you there should not be any organic carbon ever exist in the Earth's crust. And we know there is 15 million gigaton of them are in there. So it's really a simple thing. A model should explain other observation, other fields of science. It cannot be in isolation just for soil, because there was soil in Devonian, there was soil in Permian, there was always soil millions of years ago. And where are those soils? There are now rocks. And we know there are a lot of biochars, or back then it was called inertina. They were naturally produced wildfire char. And we know a lot of them are in existence. So they haven't gone away. And we could debate about, well, the preservation condition was different. Sure, but if you were saying 100 years, everything vanishes, then we have oxidation, or we have a degrading environment that is unbelievably efficient. It shouldn't let anything pass beyond 1,000 years, and then you should basically sanitize the Earth's crust once it goes through the soil. So it really doesn't explain.
Can I ask you to close off there, yeah, Hamid, just so we have some time for questions?
Mm-hmm. Absolutely.
Thanks very much. Yeah, I can confirm Hamid has sort of shared some of this research with me, and clearly what he says is quite well supported. I have not yet seen anyone come forward with evidence to show carbon loss from inertinites, so that if that evidence was available, that would be a very important thing to be aware of. As I say, I have not yet seen anything that contradicts the way that Hamid has characterized that. But let me invite Cecilia Sundberg to join us as well. Are you there, Cecilia?
Yes. Hello.
Great.
Yes. Thank you very much for inviting me. Very interesting so far, and I hope to be able to add a few things here. And I think where I would like to start my reflection relates to both of your final things here. First, your policy questions here. How should we have the modeling in a certification? And then what science is actually saying and doing. And we need to live with the fact here that science doesn't have all the answer, and the policy making can't wait for all the scientific answers. There's really a need for urgent climate action. We know that biochar is good enough and interesting enough and already available as a carbon dioxide removal. Science is also ongoing, and there's a process here, and we are now at a certain point in time building back. In a few years ago, there was the point in time for getting biochar into the IPCC, and then we've had a progress of research until today, where both the work of my research group and that of Hamed Saneh has brought in new perspectives this year. And as you've shown here, both of them point to biochar being actually more stable, more durable than the previous research. And that's, in my case, going back to the same data and a few more data points, but looking deeper to them and finding things that to a large extent confirms what Hamed was saying just here before. Also, science is not stopping here. These are not the last papers. There is more research ongoing, and there will be more coming in the future. It's important also that it will be possible to take that into account, especially since this certification is not expected to be on the market yet in until a couple of years from now. And I think some of the things that are still not confirmed, not consensus, will perhaps reach a bit further in the coming years. And just a reflection on definition of words. We're using permanence here, and I understand it as being not permanence forever, but permanent in this time frame of a few hundred years, right? That's not how I would use it neither in daily life or in science, but I'm happy to go with that for this specific purpose here. And just finally, HC ratio has been the most established method, but it's not an excellent method. And I'm very glad that inertinite is coming up on the agenda, but there can also be other indicators that could become useful with, but further research and analysis is needed before we can say that. And with that, I think I'm ready for questions.
Thanks very much, Cecilia. I do want to mention, beg your pardon, just before we go to questions that we did invite Dominic Wolf of Wolf et al. To join us today. He's based on the East Coast of America, so in all honesty, this was quite early enough for me in London, never mind Dominic out on the East Coast. So he wasn't able to join us, but he has expressed a concern that this view of biochar as being very permanent might not be capturing all of the potential decay mechanisms, and I think the point at which Dominic and Hamed, I believe, agree is that there's work to be done with something referred to as sort of artificial aging studies to try to more clearly identify whether there are carbon loss pathways. So I think, as Cecilia says, it's clear that there is additional research to be done, and that if our process is to proceed, as Christian has outlined, to a straw man proposal in 2024 and a draft methodology in 2025. We are going to make some choices in the context of science that is still developing. And I think that's going to be a common phenomenon through carbon removal certification, because we have several ideas and technologies that are relatively new. Hamid, I have one quite technical question from Anke Herold of Urca Institute that I wanted to put you, and then maybe Andrea, if you've been monitoring the questions and could suggest a few that we could go with first. But the question I noticed, Anke said the Sané et al. Paper uses a method that heats the biochar several times at high temperatures. So I think this refers to a repyrolysis that removes the volatile fraction. These high temperatures, Anke says, are increasing the carbonization. Thus, the method seems to change the original biochar and produce a more stable product. Anke asks, how do you know that the inertinites identified are not an artifact of the method and were really in the original biochar samples? So if you can answer that one quickly, Hamid, that would be great.
Well, it's not. Inertinite is not identified by any heating method. We just get the raw material, like the biochar, and we look at it petrographically by microscope. So it's basically measuring the amount of reflectivity of particles of char in one sample. So we're talking about 500,000 of readings on one single samples will be done, and the reflectivity is basically corresponding to degree of aromatizations and condensations of the molecules of carbon in the biochar. So
I think Hamid, I think the question refers to this. I don't necessarily remember everything perfectly, but I recall that your paper did describe a sort of a reheating step before testing the samples. Is that a correct understanding?
Yeah, that is basically to measure like a fixed carbon, or what we call it residual carbon. But that's not how we define inertinite. The statement.
So the question was whether that test to identify the hydrogen index and the fixed carbon could affect the sample. I think the question is whether that part of the method.
Obviously, fixed carbon, it would be influenced by reheating the samples, yes. But that is not how we define inertinite. Inertinite is merely defined by macroscopic method. So there is no artifact of heating.
Okay, so those are two separate parts of the method. There's a fixed carbon test, but the inertinite test is done on a sample that has not been reheated. Is that correct?
There is no two sets in the method. The method for defining inertinite is only one, and it is a random reflectance of 2% as a benchmark. So you could measure the fixed carbon, and fixed carbon does correspond very well with amount of inertinite at a very high pyrolysis temperature of biochar. They become almost very similar to each other. But in the lower temperature biochars, that artifact that you mentioned could very well affect the amount of fixed carbon. And I don't think this is something controversial. Everybody agrees with that. But inertinite that we're talking about, it's not using any heat. It's just basically a microscopy method.
Thank you, Hamid. Andrea, did you want to curate a couple of additional discussion points for us?
Yes, thank you very much to everyone. I see we have very exciting discussions in the chat, which is excellent. We've been looking through the questions, and we've chosen one that kind of is being repeated quite a bit, but there's one from Rink Smittenberg that I think kind of encompasses a few things, something that a few people have brought up in the chat. So here's the question. So the discussion is whether one assumes intrinsic chemical stability. or whether one takes into consideration if degradation can actually take place by microbial enzymes that can break, oxidize the condensed structures with high activation energy and gain energy and carbon by doing so. Sorry, there's a, a bit of a typo here, but I think it comes down to accessibility, temperature, redox partners, microbial ecology, etc. If anyone wants to pick this one up.
Well, I can note I did go out. This is not a literature with which I was enormously familiar when we started. I did go out looking for sort of descriptions of those sort of cases, decay, for example, of inertinite macerols in coal by microbial pathways, and I have not yet found sort of evidence that suggests that that's going to happen very quickly. But Hamid, Cecilia, could you speak to that from a position of more knowledge?
Yes.
I think Cecilia's turn. Go ahead.
Yeah. No, so I'm also been looking for this and listening in and reading and not finding much. We know that in general, microorganisms prefer substances that are easier to degrade. So in a live soil, you will find a lot of other things that are preferred by microorganisms. But there you also have a lot of biological activity, enzymes that can break down and then in the next step make substances available. We also have the physical coverage. The biochars are not expected to be free-flowing, but rather to become part of the soil, where there will also be protection from degradation, chemically and physically. Yeah, overall there is potential mechanisms leading in various ways, but there's not much in terms of evidence that the most recalcitrant are being degraded in the time periods that we are talking about here in hundreds of years.
Would you like to add to that, Hamid? Or
Yes.
is that...
Yes, and as my good colleague Cecilia mentioned, we don't have to choose between the two. You know, the method we are suggesting, it has to combine both. Well, if we had thousands of years to do incubation experiments, then we would go all with the bacterial degradation, because that's the more natural environment. But since we don't have, we need to take the amount of carbon decay during incubation for what it is, and get the decay model of that and project it. But we know the experiment has shown these are the labile fraction. For the fraction that is inert, that means it has not yet been degraded during the experiments. We need to come up with another method to create a kind of that K constant, you know, to decay it. So there are, we proposed one, we published one about oxidation, combustion, basically kinetic of that. There could be other methods, but it has to be, you know, combination of bacterial for recognizing the fraction that degrade during the soil incubation, and the fraction that is not, it has to be recognized by other mean of decomposition in order to establish that magic K constant values, which would really drastically define the permanence of the biochar that you're going to get.
Thanks, Hamid. And for anyone who has forgotten what the K constant was, K is the exponential decay rate in those exponential decay functions that we were talking about. So K is the parameter which is fit one value of K for the labile fraction, one value of K for the recalcitrant fraction. Do we have another question we would like to go to, Andrea?
Yeah, so we got an interesting one, also in the context of actually kind of implementing the certification for different use cases. So there's a question from Monica Gal. So how does permanence assessment for biochar work for materials such as concrete? So is there any difference to permanence in other applications such as soil applications? Do you have any views on kind of the permanence in those two different? Is there a difference to our considerations for those two specific cases, or any other case for that matter? Thank you.
Thanks, Andrea. So in terms of the way that this is currently handled in the certification options, there is a general expectation, which seems to me to be reasonable, that this rate of decay in soil can be taken as a conservative estimate of the rate of decay in another context. In soil, a sample is going to be exposed to moisture and microbial action in a way that it is not likely to be exposed if it's integrated in concrete, for example. There are other potential material applications, things like polymers, or for use in the anode or cathode in batteries, maybe, where there's sort of perhaps risk of end of life destruction. So you can have applications where a biochar sample may be at risk of exposure to heat at end of life. If biochar is used in a polymer and it goes to an incinerator, then obviously that is the end of the carbon storage there. The application, I think, is important, but yeah, the sense, which, as I say, seems reasonable to me, is that the material applications will be more persistent, but there's not so much research available on that. I don't know, Cecilia or Hamid, if you'd like to say a couple of words as well.
Don't think I have anything to add there.
Yeah, and the only thing I can say, we need to expose the biochar to the harshest oxidation or decomposition environment possible to get the most conservative values. And we've done that. We published that. We exposed that to the basically oxidizing degradation using heat, using temperature. Other people have used chemical things. We have to speed up, we have to accelerate this process of decomposition, simply because we don't have time to wait thousands of years to see how long does it take to decompose. So we need to speed it up just to establish the rate of degradation, which is that magic K that Chris mentioned, because that would define the entire decay function, and the ultimate number of F perm you get. It all depends on that number, that K number. You change it a little bit, you're going to get a huge difference. And that's all I have.
Thanks both. Andrea?
Yeah, this is a good, this is a good segue to my next question. And here I'm picking up several discussions and comments from the chat section. So this is about liability, and kind of what kind of liability we should impose, considering, if we take that the risk of release is low, negligent, zero. So I'd be keen to get your thoughts on that point.
Thanks, Andrea. So when we talk about liability in the case of biochar, I think there's an important distinction to be drawn versus looking at liability in the case of geological carbon storage. And that is that for biochar in soil in particular, once the material is incorporated in the soil, I think it looked like a couple of points on the chat have reflected this. The biochar can be transported. It can be taken up and down the soil column. Worms can eat it and crawl around and whatever else. You can get biochar eroded by wind or by water. So there's various transport processes, and that means that it's not really functionally possible to come back to a field 50 years after biochar was applied and come to an accurate or precise estimate of the amount of the original biochar carbon which still remains, because some of that carbon will remain in place in the soil. Some of that carbon might have been washed to the bottom of the river or out into the sea, or being transported to neighboring fields, or to have got deeper in the soil than your sample depth. So whereas in the geological carbon storage case, there are methodologies and processes that are in place to actually monitor and identify CO2 leakage. So we have a sort of a different case in terms of how you might identify a reduction. So the way that the methodologies that are already active deal with this is to use this decay function, which is intended, or which is characterized in several methodologies as giving a conservative estimate. So what one discussion point we've had is whether the Wolf et al. Function in particular can be considered conservative over a longer time frame. And I know that Hamid, certainly, I think Cecilia agrees that it probably is conservative over longer time frames, but that isn't a point of full consensus in the community. But so liability is addressed by taking an estimate of expected storage, which is relatively conservative. For soil application, it may simply not be possible to impose longer term liability by measuring things. Although if you look at applications in materials, if that material is sort of concentrated at a few locations, then it may be more practical to do continuous monitoring. So one question for our methodology is whether there could be some sort of continuous monitoring requirement that relates to material uses. Again, Cecilia, Hamid, if you'd like to add to that, please do come in.
Let Cecilia go first.
Yeah, no, I don't have anything to add there.
Okay, in that case, Chris, I think you're very kind about the CCS and the monitoring that we were talking about. They use geological perspective. They rely on integrity of the reservoirs that they put the CO2 in there. In this case, in the case of biochar, we rely on integrity of the condensation and aromatization, the conversion of molecule to something very resistant. And that's exactly why incubation studies are being done, because you want to establish the amount of CO2 released or decay due to decomposition of the biochar. If you put it in the field, I don't know how you could measure the CO2 released from biochar. It would be almost impossible, any kind of monitoring that differentiate. It would be very difficult. So I think, as I mentioned, the incubations experiments are a state of the art. And we know the establishment of inertinite is a state of the art. Both of them are well-established science. There has to be integration of the two methods, where basically the ultimate decay function or decay model better parameterize and recognize these two different fractions of labeled fractions and inertinite. Inertinite can very well be quantified. We know we can quantify exactly how much inertinite you have, and give it a decay function, a K constant, which is based on at least something that makes sense, based on the chemical oxidation or other evidence that we have. It makes sense. Something very conservative, I agree with that. Something very conservative, but still it has to make sense. We can't say inertinite will be degraded in 100 years. It just simply doesn't make sense. So combination of both would give the same thing. It would give a F perm, which could also be correlated with hydrogen to carbon ratio. For sure, it will be perfectly correlated, because we know as the hydrogen to carbon ratio goes down, the amount of inertinite also goes up. All of these are very well correlated. They're all basic chemistry. But the eventual model should capture all of these, and this fraction remaining would be something that could be relied on as a conservative way of understanding how much of the carbon would remain in the environment after, let's say, thousands of years.
Thanks, Hamid. And I notice I have another technical question, Hamid, which I would like to put to you from Rian Visser at TNO, who said that measuring inertinite by microscopy is an old technique, and suggests that there are relatively few people qualified to do this testing anymore. So the question given is whether this method is too specialist to be used in the certification procedure. So Hamid, if you can talk briefly to the practicality of that reflectance testing method.
Absolutely not. It is, you would think if it's an old technique, there are more people around to know that. So there are many people who know that. It's simple method. It can be easily established. It is actually ISO norm method. So it is already a standardized method. And there are many labs all around the world that would do that. So I don't think that part of it is a problem. But remember, also random reflectance, we published that. It correlates beautifully with hydrogen to carbon ratio and with other proxies. That doesn't mean we have to abandon hydrogen to carbon ratios altogether. We could still use the proxies to infer the random reflectance. Once the database reaches, let's say, hundreds, few hundreds, and we could reliably say, well, hydrogen to carbon ratio of 0.4 means reliably we get, almost fully inertinite in our sample. Then, we don't have to do that unless we really, as part of certification, we want to look at this under the microscope and measure the random reflectance. So I think all of these are quite practical, and there's nothing out of reach or expensive or, unpractical.
Thanks, Hamid. And I'll note that the EBI published a paper a couple of months ago, and as I understand it, sees the reflectance testing method as an appropriate method. So my understanding at the moment is that industry is happy that the cost and availability of the reflectance testing method are both reasonable. So if people disagree strongly with that, it would be very useful to get feedback on that point. Andrea, I think maybe we can try to have 3 more questions before we go to a short break, if depending on how quickly we can go through.
Yeah, I think that sounds really good. I'm going to ask one now, and maybe I invite others to put in specific questions for the last ones. So this question is more on the kind of taking a step back and looking at calculating kind of, well, more generally the fluxes. So if you put biochar in soils, for example, for which you need to plow the soil, turning it upside down, is there a way to assess kind of the carbon losses due to this plowing versus the carbon removals from the biochar? Can we kind of put that in a calculation in our certification methodology in a reliable and cost-efficient way?
Thanks, Andrea. This is not something, to the best of my recollection, that is addressed in the existing certification methods. So I think that for agricultural use, in many cases, the expectation would be that you are not increasing the soil turnover that much. If I know David Chiaramonti is in the group, I imagine he has a view on this point. So David, if you can quickly help me out, that would be useful. So my understanding has been that we don't expect to see a great acceleration in the loss of organic carbon from the soil due to this incorporation process. Certainly there would be cases sort of in the context maybe of low till or no till agriculture. I can see that if you're turning the soil over more, then you might be undermining. David confirms my understanding. Thank you, David. So yes, I can see that if you're talking about no-till agriculture and you're coming in with a reason to till, then that might lead to a temporary loss of carbon. There is evidence that biochar can enhance the rate of organic carbon formation in some cases later. This is not something that I had identified as needing to be covered in certification. So again, if people have evidence that needs to be looked at in more detail, or evidence so that I can look at it in more detail, that would be very welcome. Hamid, Cecilia, I think that question's probably not your core business, but again, if you had a couple of words to say.
I don't.
Thanks. In which case, I think, sorry.
Yeah, this relates to the agricultural practices and the soil carbon, and that is indeed complex and site-specific.
So there's maybe an associated question, which we could come back to in the second part of the session, which is whether the certification standard ought to include some set of requirements on the way that biochar is incorporated. One thing I think we discussed in the review paper is that incorporating the carbon into the soil really more or less eliminates the risk of loss of that material through fire, and also significantly avoids albedo effects. So if charcoal remains, or biochar remains on the surface of the soil for a period and is dark material, that can increase the absorption of solar irradiation. So we discussed whether it was appropriate to have some perhaps relatively simple requirements on incorporation, and maybe that requirement could include something that gets to whether the way that the char is incorporated leads to organic carbon release. If there are suggestions either that's appropriate or inappropriate, or how we could frame that would all be very useful. Andrea, do we have
Maybe
another
we have
question?
time for one last quick question before we take a little break. So there were quite a few questions in the chat referring to basically the year we set. So I just wanted to go back to this question that you have on the on your slide here, Chris, and see whether Cecilia and Hamid have any thoughts on this. So if we take the decay function, what time period should we require for the assessment? Thank you.
Thanks, Andrea. So I think this comes to Cecilia's point about the use of the term permanent. So in the context of the carbon removal certification framework, we are talking about characterizing biochar as a permanent carbon removal that delivers long-term storage, and the regulatory text clarifies that long-term storage has to be understood as storage at least on the order of several centuries. But then, if we're going to include a decay function as a certification option, then there will need to be a time frame put on it. So, Cecilia?
Yes, this is a tricky question, because the research with the on which the decay functions are built is short. It's in research context, so we're talking years up to a decade, and then we extrapolate these results into the future. And the longer we go, the scientifically less certain we will be with the results. So we can, of course, do this mathematically, it's not a problem, but in terms of interpretation, it becomes more difficult. And that is where we need to combine the modeling with knowledge about the biochars and what happens in the soil. For example, there's no reason to believe that there would be an acceleration of degradation of the biochar after 100 years. So yes, we can safely say that it's going to be same or less decomposition. but also coming in then with the kind of knowledge that Hamed is adding here. We might be able to draw other conclusions about the long term that geological knowledge can add that soil science doesn't really provide.
Thanks. Hamed, do you have any closing thoughts on this question of what an appropriate number of years, if we include a decay function option, would be?
No, I think Cecilia and you gave very good answers, so I appreciate that. Yeah.
Well, in which case, I will say thank you very much to Hamed and Cecilia, and thank you to everyone who has been writing questions in. We will make sure to take a copy of the chat. I will enjoy going back over that later. It is, I'm sure you can imagine, it's a little bit difficult for me to read everything as we go along, but clearly there's quite a bit of thoughtfulness and knowledge, which is, good grief, that really is long when I copy it, that has been brought to the conversation, which is exactly what we wanted from this meeting. So we now have a short scheduled break. I think we're scheduled for 10 minutes, and as we started a little late and we're a few minutes behind, let's try and keep our 10 minutes and reconvene at what on my clock would be about 11:18 to start on the second part of the session.
11:18 sharp. Great. Thank you so much, Cecilia, Hamed, and Chris. Yeah, so let's go to a short coffee break and see you again in 10 minutes for our second session. Thank you so much and see you soon.
Yeah. Thank you, Andrea.
Okay, hopefully everyone is rejoining us. Andrea, did you want to make a couple of introductory comments on session 2, or shall I just go straight in?
Why don't you go straight in, considering we keep running a little bit late, so I'll let you dig into the details of it immediately. Thank you.
Great, thank you, Andrea. So I'm just going to put this back on screen. Then just need to back on. Okay, so for the second part, I'm going to give a slightly briefer presentation. I'm going to talk about some of the other areas that we identified as important and sort of warranting discussion in our review of existing certification schemes. So for anyone who hasn't looked at our review paper yet, we looked first at this question of permanence in relative detail, and then we go over these existing certification frameworks that I mentioned. And we have identified that there were 5 standards that we've reviewed that are currently have methodologies available for certification of carbon removal through biochar. And those 5 were the EBC C-Sync methodology. So EBC has a sort of a production standard, and also has a carbon removal methodology. So there's 2 distinct things there. We discuss both of them in the review paper, but when I talk about certification, I'm talking about C-Sync. We have Puro.Earth, we have VCS, we have Reverse, and we have C-Capsule. There is also a standard from the American Carbon Registry, which is a little bit older, and which was not adopted. And so there is, the ACR have published the peer reviewers report and then responses from the standard developers. It's a somewhat interesting document and quite relevant to our context. But at that time, this was, I can't now remember, maybe even 10 years ago, the ACR decided not to make that an active methodology. And we also talk in the review paper about the quality standard of the International Biochar Initiative and carbon credit rating principles for biochar projects, which are published by Silvera. All of these active standards currently assess carbon removal based on looking at estimated 100-year carbon storage. So because we have the language in the CRCF of several centuries, we have a slight difference in focus there. And I mentioned that the ACR standard was never implemented, and that did reflect a disagreement from their scientific peer reviewer in particular. There's also I think there's maybe stakeholder review comments which are available as well. So there was some disagreement about permanence and about how confident one could be about permanence. Having looked at that, I'm somewhat satisfied that some of the key issues raised by that peer reviewer are resolved, and actually in some cases I felt that the discussion, the proposers of the methodology had answered several of these questions reasonably well at the time. But that, so as I say, that is discussed there, and that's a little clearly somewhat relevant to what we were discussing in the first part. The EBC guidelines for sustainable production of biochar, and that's a European biochar certification, are widely referenced as a basis for sort of governance for biochar production and quality. Issues such as level of heavy metals and other toxicants that might be allowable in biochar in agricultural contexts. And I have had the sense that those rules are fairly thorough and well conceived. So I think the review paper frames that maybe that set of rules would be the basis, or could even perhaps be directly referenced by a European certification methodology. There's some differences on biomass eligibility. So I guess the starting point for our work is to assume that the sustainability criteria in the Renewable Energy Directive will be imposed on the use of feedstock for biochar, but certainly there's some standards which are a bit more limiting than that. So for example, VCS only allows feedstock that is biogenic waste biomass and not purpose grown. And in the review paper, we discussed whether, for example, we could include that as an option by making a co-benefit available for the use of certain sorts of biomass that have some advantage in terms of sustainability criteria. There's also a little bit of variation about the extent to which biochar has to be tracked through to the point of use. And certainly some of the standards accept proof that biochar has been sold as soil amendment or as concrete amendment as the sort of the final point in that tracking chain. So we do have an important question for an EU certification scheme, whether we would require tracking to go that little bit further. So there are several issues that we identified as sort of important points at the end of the review paper. I've pulled out a subset of those that it might be interesting to discuss today. And our panelists hopefully are also going to sort of bring a view to the table on what it would be most useful to talk about today. On the question of additionality, we have several standards, I think, or at least 2 or 3 standards that use a combination of an activity penetration test. So that's just a sort of a more formal way of saying that biochar is not currently a common practice, that this is something that is not generally being done, accompanied by a regulatory surplus test. So that means demonstrating that there's no regulatory requirement to do this in a given market. And on the basis of that, treat biochar projects as additional without reference to a financial test. There is potentially with biochar, and especially if we look at processes with lower biochar yields, like fast pyrolysis and gasification, the biochar might be a relatively modest part of the revenue stream for those projects. So there's a question about whether the financial reality of those co-product systems should affect the way that we think about financial additionality. And for the CRCF, well, we have the question, should there be a standardized baseline? Should that be 0, either for all biochar projects in an initial standard or for some biochar projects? Or should an activity-specific baseline be required? And just a reminder that in the CRCF language, a standardized baseline may be set, and then additionality will be assumed for any project that beats a standardized baseline. In the case that we use an activity-specific baseline, then there would be an expectation of an explicit regulatory surplus test and financial additionality test being undertaken for those projects. And then have a question about co-product accounting, again, with potentially a mix of products leaving a biochar production facility. When we look at GHG associated, should emissions be allocated between those co-products following energy-based emissions allocation as it is done in the Renewable Energy Directive, or is there a case for a slightly different approach to allocation? And then I've already mentioned demonstration of use. Should we require that the use of biochar be tracked beyond the point of sale, down to the farm, down to demonstrating that it's been incorporated? If going over to the point of sale, could or should there be a requirement that biochar be sold in a form that makes combustion impractical? So this is an idea in at least one of the existing standards that if biochar is sold already sort of intermixed in some medium, so that could be mixed with manure, mixed with soil, once it's into concrete, it's not practically possible to pick all of the biochar particles back out and use it as a fuel. So that's a potential requirement. And I've already mentioned this question, should we require incorporation rather than allowing the biochar to be left on the surface? Then on sustainability and co-benefits, I mentioned when I talked about eligibility, could we define a co-benefit in the standards? So the CRCF framework encourages, or it says that where possible, sort of co-benefits, sustainability co-benefits on the 6 sustainability areas I think identified under the sustainable finance taxonomy. So those 2 relating to climate change. Then there's circular economy, air pollution, water resources, and I should be able to list these 6 because I was part of that process, but I apologize, I've forgotten which one I missed for a second. But can we define co-benefits relating to a specific subset of feedstocks? Could there be a co-benefit defined? So by defined, what I mean is we could set rules that allow this to be recognized in the certification process. Could a co-benefit be defined for application that maximizes the agronomic benefit? And as I mentioned earlier, is there agreement that the EBC production guidelines are a sound basis to manage some other sustainability risks? So, for example, especially for biochars from waste materials, there can be a little bit of, there's the potential that you might have toxicants, heavy metals in that material, and that you want to limit that use, in particular in soils, maybe with slightly lower thresholds in materials applications. So those are the slides. As I said, we've got some discussion points, and I would like to invite our expert group panelists to join us to give a few minutes of remarks each, and maybe we could start with Martin Pigeon from Fern. Martin, if you are there and your mic is activated. Do we have Martin? If Martin is not here or has an issue, perhaps we could go to. So I believe Martin hasn't been set as a presenter yet. Andrea and team, can we upgrade Martin?
I think Martin has dropped off while we try and get him back. Maybe we continue with the other panelists. Sorry about that.
Martin is posting in the chat, so I think he ought to be there. But maybe we can go to, with apologies, Martin, we'll try to come to you a second or third. Let's see, Amelie and Julie Marie, are you there and able to to speak?
Yes, yeah, we are. Yeah, so my name is Julie and this is Emily, and we're from the Danish Ministry of Climate, Energy and Utilities. Yeah, and we can share a few words on our work with biochar. First of all, thank you for the great work. We think clear guidelines for the certification of biochar is important and should be ensured. So we are very happy to receive this paper, and we look forward to the following work. Yeah, Denmark overall support creating a credible framework for carbon removal activities in Denmark and in the EU that will support carbon removal activities in Denmark and EU. And we believe that it should be done on a sustainable basis. We wish to help create the certification framework that will enable the credible certification of carbon removals. Yeah, Denmark support to certify storage in biochar as permanent. We believe that it will increase the subsequent market value of biochar certificates, and is assessed as a potentially important consideration for the spread of pyrolysis as a technology. In order to facilitate market development, the Danish government is currently working on a national biochar strategy targeting carbon removals in the agricultural sector. So it is storage on agricultural land. And the main goal behind preparing and adopting this national strategy is to establish the regulatory framework for the production of biochar and also the use of biochar in the agricultural sector at a larger scale than today. But this strategy has not been published yet, so we can only share a few insights with you. But hopefully on the expert meeting in October, we can share more. Yeah, so one of the issues we have in Denmark is that there's not identified this official IPCC method of accounting for biochar in the national inventory. So this makes it difficult at a national level to assess the expected long-term carbon storage of biochar. Because in our understanding, the method of IPCC is only considered like a potential basis for future development of an accounting method, as we have talked about today. So to tackle this issue, Denmark is in the process of tasking a scientific institute with the development of an accounting method for biochar in Denmark that meets the IPCC requirements for the national greenhouse gas inventories. And furthermore, an important thing for an important barrier for producing and storing biochar in Denmark is that it has to be there has to be a regulatory framework for producing and using biochar that lives up to environmental regulation. So in Denmark, we have started field trials that span over multiple years, and also trials that will measure the production of biochar and potential negative environmental parts of this biochar. So these trials will help collect data so that the Danish government can make a regulation for biochar that lives up to environmental regulation. Yes. And we generally believe that it is important to consider other storage options as well. For example, in building materials and concrete, as we have talked about today. But as the current IPCC guidelines do not cover storage in other than agricultural land, it is not something that the Danish government is working on supporting storage in building materials. But to get a better understanding of this, the government will commission a knowledge synthesis on this matter later this year. Yeah.
Thank you very much, Amelie and Julie Marie. It looks like Martin is now going to be able to present. So Martin, if that is true, perhaps you could make your comments now.
Happy to. Hello, good morning. Thank you very much. Can you hear me well?
Yeah, yes, loud and clear, Martin.
Beautiful. Thank you very much. So thanks a lot. It's a really interesting discussion because it is a very interesting topic. And one of the reasons it is very interesting is that it is very easy to make biochar, actually, unlike very, capital heavy things like BECCS or other things. Making charcoal can be done by anyone. We also know that charcoal production has been a leading deforestation and air pollution driver for a very long time, in fact. And we also know that using chars in soils can also have toxic effects on the soil themselves and plants at too high doses, because the chars typically contain, toxicants. So it's just to point that it's setting up policy incentives for using biochar therefore needs to be done very cautiously to avoid these consequences. All the more that the best quality chars, in terms of permanence in particular, would apparently be produced from wood more than crops. Biochar incentives need to be crafted well enough that carbon removal from the atmosphere are actually obtained and do not cause additional deforestation, air pollution, and soil toxicity. And I'm concerned that the report and the standards reviewed do not yet achieve this. Let's hope they do. I'll comment on 3 points shortly on the sustainability of the biomass, of the sourcing, on the permanence, and on the toxicity. I very much agree with, and I think everybody does, with Mr. Holzleitner that the sustainability sourcing of the biomass is key also for the credibility of the credits generated. Like with bio-CCS, biochar extracts carbon from the biogenic pool, not from the atmosphere. So what you want to ensure is that the new growth that ensures that that there is new additional growth that secures this and that secures actual carbon removal. Otherwise, and it needs to be additional, otherwise you're simply displacing demand. The biochar production causes additional biomass demand somewhere else, and there is therefore no removal from the atmosphere overall. That's why there is a strong insistence on the standards on waste and on residues, because indeed you want to only use things that have no competing uses and with a very, very short carbon payback time. But my concern here is that there is already a very, very high demand for these things, for bioenergy, for material uses. I mean, this has been mentioned, but there is already today too much demand compared to the sustainable supply of it. We have a situation where the European carbon sink is going down and has been going down for more than 15 years, and with sort of 80% of the disturbances in forest caused by forestry and logging operations. And so I think it's really important that this does not cause additional extraction of carbon from the carbon sink. On permanence, very shortly, because I'm really not in my realm of expertise here, but I saw that indeed, as this was discussed a lot, there was a lot of reliance on incubation studies, despite it's quite obvious that the specific soil conditions have a big impact, in fact, on the eventual behavior and of the carbon. So I understand that waiting for thousands of years, to observe what's going on is not realistic, but I was very interested to hear more about what Denmark is doing, because, characterizing the behavior of various chars over a few years in various soils and environmental conditions can be done, and should be done, actually, to generate the knowledge that we need to have something that sort of holds water. And last but not least, on toxicity, toxins in biochar don't just stem from toxins in the feedstock. You have things like polycyclic aromatic hydrocarbons and dioxin formations that results from the production processes, especially at low temperatures, which are, however, optimal for producing large amounts of char. And I don't see that the EBC certification, for example, prevent high levels of dioxins. And I did not find a lot of this in the report, which should really be included. And that's actually another reason why observation studies are so important, because there again, soil properties are going to matter a lot. You can also think that when the biochar is used in construction materials, this could also have possible consequence in terms of indoors quality. So wrapping up, we are very happy that the nature restoration law was adopted yesterday. Extremely happy. It's years of work. We also hope that the forest monitoring law, is going to be adopted in the coming term, but we cannot count on these legislations to mitigate the effects that excessive incentives for biochar would have. The way it happened for bioenergy use. We've seen how long and difficult it has been for the EU to correct its initial bioenergy mistakes. Let's not do the same with biochar. That said, thank you very much for having me, and I look forward to the rest of the discussion.
Thank you very much, Martin. I had a couple of immediate responses on the chat, so I will note that there is certainly a test for dioxins as part of the EBC standard. I did have at least one person express a concern about whether those thresholds were appropriate. So this is a point on which I would be interested to have any further input. If anyone has a firm view that the standards for dioxins ought to be strengthened, then that would be relevant to hear about. Let me, however, invite Anna-Lena of Carbon Future to give us our third contribution before we go to a broader discussion and take some questions. Anna, are you? Yes.
I am. Thank you very much for inviting me to this discussion. And the areas of expertise that I could try to contribute here are the ones of being a materials chemist. So I spent a decade looking into structure and property correlations for functional materials. And as we've seen and know, biochar is very much a family of functional materials. And we'll hear about that more. The chemistry lens for the toxins and also for the permanence and durability under various applications. I think on that trail, I'd like to comment on the fact that we are slowly transitioning to not just speak about emissions and removals, but highlighting more the pools of carbon that they are coming from or going to. I think that's a great development, and we have to move it into the larger society discussions where we really have this small cycle of carbon coming from the atmosphere through the biosphere being transmuted and reacted from different molecules that contain carbon, and that's really the basis of life, this flexibility. But then we have a larger and slower carbon cycle that equilibrates with the atmosphere only rarely and in small amounts in the geosphere, where we also need to see how we can count the materials technosphere into it, and really the doors into from the small cycle in the large one are twofold: the inorganic pathway with the minerals and carbonates, and then the organic pathway with the macérals. And carbon removal, the durable one, is just what we do is speeding up the pathways to the long-term cycle. So that's great, and I like that it's being covered in methodologies really on this basis of physical and chemical properties, how they relate to the materials that we're dealing with. And on the other hand, I represent Carbon Future here, so a practitioner in the carbon removal ecosystem. My work is on standards and methodology integrations there, so I'm facing standard authorities and receive from them their eligibility and quantification requirements to certify durable carbon removals, and we then implement them into our digital MRV infrastructure, trust infrastructure, where we aggregate data from suppliers and streamline a reporting for the validators, verifiers, certifiers, to really remove bottlenecks in certification and connect supply and demand. And for that, we started about 4 years ago. There were 2 emerging biochar protocols by Puro and by Carbon Standards International, back then the Ithaca Institute, now hosting the EBC and the EBC C-Sync. And it was interesting to see how those biochar methodologies evolved over the years. And at the end of 2024, we'll have about, I think, more than 8 different methodologies, both for the characterization of the material and the production, and for the carbon removal. And the most striking evolvements that I saw, that we witnessed as trends, while these methodologies have been evolved to match the active delivery of biochar carbon removals in the ecosystem among a lot of suppliers and buyers, and a good handful of standards coordinating this, is the first one. Let's say they got more differentiated on the biomass side and also on the application side. We've heard a lot about that already. So the sustainability of the biomass is absolutely crucial. The removal, of course, starts at fixing from the air. We can't just start at the biomass and say it's a given. We have to make very, very sure that it's not taking biomass from other applications that we need, or that would lower the net carbon removal of the whole value chain. So that has been differentiated. And also on the application types, of course, we have a range of new processes and a lot of innovation going on. And we've seen this as in positive lists of application types to help the operators navigate what kinds of biochar they can put in what kinds of application for what kinds of removal claims, then hopefully soon to be specified. So there is a increased complexity. And then a second trend I see is that the need for fitting the industrial value chains that we have for carbon removal using biochar is being done in the methodologies more and more. So we see certification periods getting more short-term, in principle approaching a near real-time credit issuance, which is possible, obviously, because we have, once the biomass is here, it will be days or weeks until we sequester carbon durably. That's much shorter than we were used to in the area-based afforestation, reforestation, or soil carbon removals. So we can follow materials and track them physically through space and time and do this chain of custody tracking. And as soon as the removal has been demonstrated, credits can be issued. And that requires a whole different architecture of data intake and transport communication to the bodies who do the validation and verification. And we've seen that as a collaborative effort between suppliers, standards, VVBs, and of course designated MRV providers. As a consequence, both this risen complexity and the need to adapt to industrial value chains, that methodologies are not just written as PDFs and posted online, but it's really a monitoring plan becomes something that is a tool, that is a data intake form, that is a project hub, that is something supporting the operators to just enter the data that they know about, and they can do it very often. So really just giving the output performance of their biochar production, tracking big bags or trucks, and that will have to be repeated. So we're paying much more attention on automation and efficiency of the certification with this first durable removal type that we really get into practice with. And I think that's a good use case to also see how to implement certification governments for the other durable removals that are all quite similar in that you have to follow a long chain of custodies, integrate industrial value chains, make sure that you allocate co-products and make it modular to combine different entities who are all part of one value chain, and figure out who is the one who registers the removal in its entirety and is then eligible to receive the resulting certificate unit, and who's also liable to provide this data. Yeah, that's from me. Thank you.
Thank you very much, Anna. So we have about 35 minutes for some discussion and to take some of the questions that have already come in and new questions. I had the additionality question at the top of my list, and I saw that the chat, Christian Wertzer had also just raised this. He asked whether financial additionality requirements were appropriate in the context of, well, the exact words, why should it be excluded to certify carbon removal from something that has significant value in itself, if it would be the ideal way of carbon sequestration, a negative carbon material with a use case. So we'll make a sort of an observation on the legal language that we have, which of course my team and the Commission is working to. The CRCF regulation is quite explicit that additionality is at the heart of the quality criteria. So we have additionality there. In terms of our process, that isn't negotiable. In terms of the logic for including additionality and the role of additionality in the voluntary carbon market, I think that it would be fair to say that many and perhaps most of the customers in the voluntary carbon market want to be supporting additional actions by making those investments. So if there was a sense that biochar application was profitable and was being driven forward solely on the basis of its agricultural value, there would be a question mark about whether it was necessary or appropriate to take revenue from those customers in the voluntary market to support it. I suspect that, I think someone else made a comment similar to the one I'm about to make, but I've lost the scroll or lost track in the scrolling. I think that what we're probably talking about is a process which has a mixed value, where the carbon removals market will provide a significant value and be an important part of scaling that up. But it certainly does have a different character than, for example, the direct air capture market, where we're looking at processes that really get, or that clearly get their primary or only value from carbon credits. So Anna, I know that you have a view on additionality, and then maybe Martin, and then Amelie and Julie Marie, if you would like to make a couple of comments on these additionality questions, that would be great.
Sure, my pleasure. I agree that the additionality is extremely important as we're looking to sell certificates for units from one entity producing the carbon removal to someone purchasing it. Then, of course, we have to make sure, because resources and time is limited, that we are not wasting resources on something that would have happened anyways. That is very clear. I still think what Christian Botza mentioned here, that if we have an update, an innovation to an industrial value chain, to the production industry, where we can combine delivering materials that are useful with sequestering carbon, that is the ideal. We'll have to rebuild all our production processes. People who are moving around materials anyways need to make sure that they're moving carbon in a way that it sequesters from the small pool into the large permanent one. So definitely we need to orchestrate those incentives in a way that once they fall potentially out of a voluntary trading scheme for certificates, there will still be the incentive to do it under a compliance scheme or under another sort of incentive where industrial value chains are required to use those new technical innovations that we have available. So I think that would be my direct answer to this question. Happy to speak about additionality more general, where we believe that it makes well sense to have a standardized baseline of 0 for durable carbon removal. It's just something that doesn't happen by accident. It's definitely something that's human enhanced always. Still, it makes sense because what we said, the certificate needs to have a value that is clearly additional and someone can make an investment into it. We would suggest having an additionality test on the activity level as well, looking into regulatory surplus and then also financial additionality of the project.
Thanks very much, Anna. So just to clarify a point about how this language is used in the regulatory text. When I talk about a standardized baseline in the context of the regulation, we have clear language that says that if a standardized baseline is set, then an additionality test will not be required. So that's the particular language. So we could have an activity specific test that presumed that the baseline would be 0, and that accompanied that by additional testing.
Right.
So in the language of the CRCF, that would be what we call an activity-specific baseline rather than a standardized baseline. And then Martin, would you like to come back?
Yes, shortly, because a lot of good things have been said. Biochar is indeed used in agriculture and has been used for a long time. It's what I see is that it's really specialized uses, like it's in vineyards, for example, and the really good ones who can afford it, or towns and cities also use that to supplement their soil. So you have this existing market, and what we're discussing here is the potential scaling up, and this is what I'm interested in. I'm not discussing, what's going on now, because that's well controlled between people who know what they're doing. What we're looking at is a potential scaling up if we connect the agriculture markets and the carbon markets, and the experiments we've done there in that space call for caution. Because you can end up with new actors coming in and new users coming in, and that is contributing to the additional competition and additional demand for overall biomass, and this is not what we need. So how do you scale up in a way that safeguards what we need to safeguard is essentially my concern, and I don't have an easy answer to that.
Thank you, Martin. And if Amélie and Julie Marie would like to come back in on additionality or on any of the related points that have been raised.
Yeah, I think we agree with what has been said, but in our work with additionality in like our own climate outlook, we have made like an analysis of the Danish market of biochar, and our findings in that is that it's not profitable to produce biochar at a larger scale. So it might be profitable at a very small scale, but we have not found that the biochar has a value in itself that makes it profitable to produce it. So our findings there is that every like new biochar production will be additional. We do not believe that either that it's profitable to produce bio oil from pyrolysis without some extra support from the government or credits. So we're counting with 100% additionality when we scale up this market.
Thank you. So to come back to a comment that Martin made earlier, you would say that you could sort of characterize the existing biochar market as relating to relatively niche, higher value agricultural applications, and that market at the larger scale that we might be looking for for carbon removals wouldn't be supported by the value of the biochar. I think we have some agreement that that's probably true. If anyone would like to disagree with that, please jump in.
It's just very hard to predict how a regulated carbon market is going to behave, right? We've seen how the ETS was permeable to policy manipulation. If there's a will, there's a way, I don't like this general, what is it? It's not the incentive, but it's this call for urgency, that we don't have the time to wait. We need to go fast. Well, we need to make sure we're not worsening the situation, please. It's always the same problem. I'm speaking coming from the bioenergy world, which this is what has happened, so this is my caution.
Thanks, Martin. I think that we could maybe let's go to some of the questions that we have. Andrea, have you picked a couple of questions that we could take?
Yeah, I have a couple, but maybe before switching to another topic, there's one that I picked up, one new one here on the topic of additionality. So, and kind of moving more into, so recognizing that there are multiple co-products to producing biochar. So how do we kind of account for those? Are there any specific challenges to expect or to consider, as we develop the methodologies when it comes to kind of accounting for co-products and therefore kind of valorizing multiple revenue streams for biochar? If there are any views on this one.
Thanks, Andrea. I think I'll reiterate, I think a point that I made earlier, that you probably have a couple of different processes, some slow pyrolysis processes, which are very much focused on the biochar production, where the number of co-products might be more limited, or the relative value would be more limited. And then we have these fast pyrolysis processes or gasification processes that might be looking to supply, for example, fuels into the regulated RED and refuel EU market, where you would have policy value and commercial value, and a sort of a more complicated thing to assess. Did any of our panel have any further thoughts on the challenges that go with that if we think about financial ways of looking at additionality?
Yeah, definitely happy to go here. I think that's a good topic to look at the different ways how we produce char, how we pyrolyze biogenic materials into something that's more aromatically condensed pure carbon. And Martin, you mentioned production of charcoal. That's obviously a practice that has nothing to do with the high-tech facilities of making biochar in Europe that would be applicable under the CRCF, and we can be sure that they would not be allowed regarding both how the feedstock is cut down from woods currently, and also how the emissions and air pollutants are handled during the production. So definitely that is not a process that can be compared. And in general, then, if we're talking about co-products, I think it will be interesting to say, what's the main product? Are we saying that the product actually is the carbon removal certificate that could be sold separately as a unit, depending the use cases that will come? But then a co-product already is the biochar, and then there are additional co-products to biochar, which could be bio oil, tars and vinegars, but also then the heat or the electricity made from the heat. And as we've heard, there's, from the technical way how to operate this kind of process, there is a lot of screws that you can turn and optimize to either get more char out of it or get more heat produced. There is, of course, a baseline requirement on the sustainability on that you always have to use the heat under the, for example, EBC certification. It's relevant to use 70% of the heat, and I think that's definitely valuable to have these constraints. Regarding the value and the economic value of the co-products, what we heard from Denmark is what we can also support in working with the biochar producers that we are globally. It's difficult to get biochar operations set up with the physical products only. It's not possible in almost all the cases. You need carbon finance to get this going. Especially the bio oil is also something where, depending on regulation where you are, it's not easy to just introduce it as full fuel replacement. Often it's low quality, and the contaminants are not in a way that you would be producing it. You rather want to minimize that, and then you focus on making clean biochar and heat and electricity on the other hand. And I think this energy-based allocation of value makes sense for now. It also puts the renewable energy produced in biochar, in pyrolysis and gasification systems on a level playing field with other renewable energy sources. and allocation based on a systems expansion could be done. I would rather favor for a relatively leaner way or more standardized system boundaries across those projects that we can lead into certification in a more streamlined way.
Thanks, Anna. Did I have another comment before we go to another question? I think we can, Andrea, if we have another question, we can maybe, maybe we could go to something from the second slide, but whatever you have lined up.
Well, maybe I've wanted to ask one that's picking up on some of the themes in the chat and also some of the themes in the responses so far. And that is on kind of the temperature at which the biochar is being made and whether we need to set any rules regarding that in our certification methodology, kind of considering that the higher the temperature, kind of the more solid, stable, the biochar is, and kind of, the more certainty we have as regards to permanence. And I was wondering what the impact on the toxicity, for example, is. And I'm asking this in the context of some of the topics on kind of the co-benefits of biochar. So I guess the idea is that the more stable it is, the less co-benefits in the soils we have. So this is a trade-off that we need to consider. So I'd be kind of curious to understand whether we should aim to set any kind of minimum temperature rules, and kind of whether, what the trade-off is, what the kind of balance between the co-benefits to soil when there's a soil application are, and whether that's something that we should be considering. Thank you.
Thanks, Andrea. And I will note that I think when we had our last expert group meeting, we discussed as a sort of a comparable requirement whether you would set a threshold or a tighter threshold on the hydrogen-carbon ratio. So as we heard earlier, the hydrogen-carbon ratio tends to be reduced by higher temperature processes. Several existing standards, possibly all of the standards we review, set a maximum on the hydrogen-carbon ratio of 0.7. I think some of them set a minimum temperature of 350 degrees centigrade as well. So we had discussed whether a lower hydrogen-carbon threshold of 0.4 would be justified in this carbon removals context. But Anna, Martin, Amelie, Julie Marie, would someone like to react to that? Anna would.
Sure. There were a lot of things in the question. Thank you. So the first one, you said there could be a link between the co-benefits and the permanence, saying that if you have more permanent fraction, then you have less co-benefits. I don't think that is true, because we really have to see what kind of co-benefits and what's the structure and physical property of the biochar that's relevant here. So one of the properties biochar, even the permanent part, especially the permanent part, has is a large surface area. So we'll have graphite-like layers of carbon that's highly condensed, but it won't be stacked perfectly. There will be cavities and pores and a lot of spaces for ions to absorb and for water and moisture to be trapped. And so that could be a way to capture nutrients, to load biochar up, and then it slowly releases them and also capture moisture. That is all possible with a perfectly graphite-like biochar. And the additional co-benefits then for the carbon, whatever we call them, like the less highly condensed hydrocarbons to carbons, it's all a continuum that can get degraded by microbial influence or just in the soil chemistry. There also the benefit is, it's complex, of course, but it's not like someone's using the carbon as nutrient directly. It's all how it's related to facilitating the nutrient uptake and the soil properties. And you probably, even if you make very high temperature inertinite biochar, you'll have enough free hydrocarbons, you'll have enough edges to these molecular sheets where nutrients could be trapped, and this soil chemistry, this rich platform of reaction can happen. So that's the first one. And then regarding whether one should limit or require a minimal temperature, I think temperature is just not enough. The production and the resulting biochar from a variety of feedstocks, the moisture of the feedstock, the particle size, the dwell time, it's more complex. It's not enough to just say temperature must be that. And the good news is that on the other hand, we can really look at the material outcome. We can look at the biochar itself and say, this is enough. The H2C ratio is fine, or the carbon content is enough, or the random reflectance, conductivity, other metrics. That would be good. A requirement for the temperature rather comes from the toxicants, for the organic contaminants coming in through the feedstock. When we, for example, look at sewage sludge biochar, we have toxins that are organic in nature, so they have carbon backbones, and they can be destroyed by pyrolysis temperatures above roughly 450 degrees. So that could be a minimal basis, but it's not because of the permanence necessarily. It's because of the requirement to get rid of some of those toxins. And then I think those were the most striking points that I wanted to respond
to. Thanks, Anna. Martin, Amelie, Julie Marie, if you would like to react further. I have a hand up in Denmark. Please go ahead. Then Martin.
Yeah, we have a comment to the potential formation of toxic substances in the biochar. That there is this fertilizer regulation in EU that set the limit values for biochar as a fertilizer product, but Denmark has been in dialogue with the Commission, and that has informed that these values are not applicable to a large scale. It is not assessed what happens if you spread biochar year after year. So there's not accounted for the risk of accumulation in soil over time in these limit values. And that is one of the reasons that we in Denmark will have planned this research on the potential formation of toxic substances during the production of biochar. And the outcome of that research that will set the limits for the Danish production.
Thank you. Just before we go to Martin, I guess in relation to this point, we have not discussed in the review paper or previous meetings whether there might be, for example, a maximum standard on sort of cumulated application to soil. I don't know whether that's something that we would need to consider, but if there was a feeling that there was a need to consider maximum application requirements, then it would be useful to have feedback on that. I suspect that to some extent this ought to manage itself if there's an understanding of any risk associated with excessive application. But Martin.
Yeah, so I wanted to emphasize a comment that's been made in the chat that I think is very, very important, is that we are also in a situation where the soil organic matter levels in Europe tend to be too low and sometimes dangerously low, especially in Southeast. And that is because of decades of excessive fertilizers and use, and also tillage, which might be a traditional practice, but is actually a disaster for the soil. And so if biochar can have a use there, it should be used. The problem is how and where and how much. And this is where I'm concerned about using it as a proxy, because indeed we have, and that goes to your question, Chris, about should we put a maximum threshold for biochar application on soils. On which soils? On sandy soils, presumably you're going to have a higher threshold because it's going to make a big difference. On soils that are better balanced, less so, etc., etc. And this is why, again, we need so much these observation studies. And I'm not a specialist at all, not even a scientist in that field. But my understanding is that there is a depth of knowledge there, and it would be very, very badly needed.
Thank you,
Yes,
Martin.
briefly.
Oh,
If I may, on this point, I agree that, of course, regenerative farming practices and whatever we're learning about how to build soil carbon better needs to be incorporated. But I would see it rather in a place that, regulates fertilizer of products. I believe that in Europe, we're not just tossing stuff on fields. So I would see definitely we need to make sure that the biochar that comes out as or is a product of the carbon removal here is specified and limited in a way that it's safe. But then regarding the different application types, whether it will go into construction materials or in animal feed or in urban agriculture in wherever, will of course have to heavily depend on what the requirements are for those kinds of products. Be conservative and try to deliver a product that's optimally clean wherever we can, and limit the use of feedstock to a very sustainable fraction, but then leave the regulation to the product level of the various applications.
thanks, Anna. And on this question of the way that biochar can be used and this sensitivity to local conditions, again, we're interested in whether we can define or set one or more defined co-benefits within the regulation. So this would be an additional point that could be certified that we would hope that might be valued by the voluntary market and therefore provide an additional incentive to follow better practices, sort of above minimum standard practices. So if people do have views or feedback on what may be an appropriate way to set a definition for a co-benefit from a greater contribution, for example, to soil restoration, then that's something that I'm very interested to get further feedback on. We have about 4 minutes on our scheduled time left. So, Andrea, if we have one final question we could go to, then we'll take final comments and invite the Commission to wrap up.
Sure. So I have, maybe I packaged 2 questions together. So I would just add to what you were saying. I would just add a question as well of the risk of double accounting of kind of carbon removal. And this is also kind of coming from the context of our carbon farming methodologies as well. So, you know, if we, how can we kind of put these 2 together to avoid, you know, if we actually attribute benefits, co-benefits to biochar in soil applications of, you know, additional removals in soils, how does that kind of fit, interact with, you know, additional, you know, practices that could fall under carbon farming, where we could potentially use biochar to increase soil carbon. A bit of a winded way of saying, you know, is there a risk of double accounting? And I also just wanted to then continue on the topic of soils, and picking up on some of the questions in the chat that were talking about, that were asking about the impact of acidity. So if we have any views on kind of both the impact of more acid soils on the permanence of biochar that is being put on the soils, but also what is the kind of impact, what are the quantities of, let's say, kind of that co-benefit? Is there a difference between, you know, co-benefits when it comes to more or less acid soils? if we have any views on that. Thank you.
Thanks very much, Andrea. To further on that question of sort of double accounting, I think that this relates to the possibility of certifying a temporary carbon removal associated with enhanced organic carbon formation, maybe alongside a permanent carbon removal. Also, within the specific context of permanent carbon removal, we wouldn't want to credit, or I would see any associated increase in soil organic carbon as sort of out of scope for permanent carbon removal certification. But there is a question which I think comes up in one or two of the methodologies about whether you could think about offsetting some of the emissions associated with biochar production, especially if they're if you have any short-lived climate pollutants, if there's any methane term, whether that could be offset by an assumption about some organic soil carbon sequestration. Sorry. Anyway, so if any of our panel has responses to that reasonably long final question, and perhaps also a final comment before we go to the summing up, that would be great. And if someone would like to go first, please volunteer. And if no one would like to go, there we are, Anna. Thank you.
Of course, happen to you. So I like what you suggested. I think when we get behind this concept that we have a durable fraction of biochar, it's highly inert, and we can quantify that as permanent removal, then the rest is still there and it happens. And that could be then put into the realm of soil carbon and used and treated and quantified in whatever methodologies are developed there. For the co-benefits, I think it makes sense to discriminate between greenhouse gas related co-benefits and non-greenhouse gases related ones, and try to not conflate it too much. I think it's very valuable that we have the sustainability as a value and as a core requirement in this certification. And we just need an effort European-wide to better quantify what co-benefits are as they facilitate an economy within the planetary boundaries. So it will be whatever we put into the environment as pollutants, but also beyond the climate perspective, how we interfere with nutrient cycles and water and air. So that needs to be all somehow governed in a quantification scheme, and that will not be just relevant for carbon removals, but for all kinds of industrial activities that we have. So I think that should be a greater initiative. And then as we learn and are able to better quantify co-benefits, we could also use that as an incentive, but probably not mix in too much and try to kind of get the carbon equivalent impact of a co-benefit. I would rather keep that a bit apart. For the acidity and permanence question, our understanding chemically, if we have something that's close to being graphite, it's really hard to dissolve. It's tough. You can like use perchloric acid in the vanadium catalyst to solve graphite, but that's not what we're talking about. Then of course the soil, the living soil and how it interacts with the more degradable and labile fraction, that is definitely something that's pH dependent, but that's a bit beyond of my expertise too much. And that's, again, the question of finding the good biochar soil pairs that are really beneficial. And we have a lot of studies already. And maybe to sum up, I think definitely it's a very, very complex topic, but the benefit is that we're already doing it and we're learning so much. And especially in Europe, we have such a thriving industry and ecosystem. And if we can manage to leave space in the methodology for all this data and all the learnings and find a way to streamline and standardize the findings in a way that we can continuously learn and collaborate to shape an even better quantification and raise the quality bar for sustainability, I think we're on a very good path. So thanks.
Thanks very much, Anna. Martin, would you? Thank you.
Yes, thanks. On the acidity and permanence question, I don't have the expertise to answer that. I just wanted to make a sort of final comment, since you invited, to insist that carbon removals via biochar can only be achieved really if you're using biomass that's additional to the other uses, and you're using biomass that has very, very short payback times. So you're actually using real residues out of processing residues, for example, or things like that, for which, as I said, there is already a strong demand. And so the question, I think, is how to free up supply if you want to create a biochar market that's looking like a market and not just a few niche applications. In a context where you don't have that supply really, it's not free. You need to free it up from somewhere else. I have a suggestion. It is to remove the bioenergy incentives. We have a better use I visited actually a biochar production facility. It was very proud of what it was doing because it was using wood pellets, a very condensed form of wood. Sorry, please use wood. If you're using wood pellets, at least put them in the soil, reinforce the soil health. Do not burn them and put them up in the atmosphere. This is the obvious low-hanging fruit I think we have. Politically, it is difficult. It is very difficult. Member states are relying a lot on bioenergy to reach their renewable energy targets. Hopefully we'll get there at the next revision of the Renewable Energy Directive, but the supply will need to come from somewhere, and this is a suggestion. Thank you.
Thanks very much, Martin, and therefore I give the final comment before we go back to the Commission to Amelie and Julie Marie.
Hi, so just a quick comment or a quick support for the co-benefits being separated into greenhouse gas related ones and non-GHG related ones. I do support that point from Anna. And then with regards to sustainability of biomass, I think I agree a bit with Benedict in the chat that we do support sustainability of biomass use. It's very important. But the use of biomass should not necessarily indicate whether how that sustainability is defined. The sustainability of biomass should be defined overall and not dependent on the specific use case, in our opinion. So just a quick comment on that.
Thank you very much. To very briefly react on this point of distinguishing co-benefits, we do have in the legal text this reference to the 6 co-benefits that are reflected also in the sustainable finance taxonomy. So my understanding is that if we define a co-benefit, it will be clearly linked to one of those areas. So that distinction is sort of already required and anticipated in the text. And on that note, I will pass back to Andrea or to Christian to close the meeting.
Thank you so much, Chris, and thank you very much to our panelists, both for the second session and the first session. And many thanks to everyone who's been kind of putting comments, thoughts, questions in the chat. That promises to be a very interesting read. So yeah, I think we've had a very, very interesting and thorough and detailed discussion. So we'll go through all of the kind of insights shared, and as mentioned before, this will feed into the thinking and kind of the work that we're doing on the development of the biochar methodology. So thank you very much for all the input. As I mentioned before, we've recorded the session, so we'll make it available afterwards as well. And yeah, it will the outcomes of this will feed into the kind of recommendations papers that Chris and the team are preparing. So yeah, again, I think this was a very successful first webinar. So I would just take the opportunity to invite everyone for to our second one on peatlands in July, early July, and then further ones in autumn, so after the summer break. And yeah, thank you very much all again from the entire team at DG Klima. I really appreciate the time, and have a great day. With this, I think we can close the session. Thank you.